Hello everyone, today we're going to look at the rectangular coordinate system and domains. So you've probably seen the rectangular coordinate system before. It's also called the Cartesian Plane, but we're going to go over it in detail anyway. So what you have to know is that it is made up of two number lines. We have the x line here, which is the horizontal, which is the independent axis. We talked about independent and dependent before. So it's the independent axis. The y-axis, which is the vertical axis, is the dependent axis. These two lines break up the system into 4 quadrants, and the first quadrant is the upper right. We denote it usually with Roman numerals, so Q1, 1 being an I in Roman numerals. So that's quadrant 1. And then we move counterclockwise. So if I go counterclockwise around where they intersect, which is called the origin. If I move counterclockwise, I hit quadrant 2, which is the top left, then quadrant 3, and then lastly quadrant 4. Okay. Now this origin is considered the point 0, 0. So we talked about ordered pairs also earlier. Remember, it's the x value and then the y value, the independent and then the dependent. So where they intersect, the origin is considered 0, 0. And then as we move to the right in the x direction, our numbers get larger. 1, 2, 3, 4. And as we move to the left, they get more and more negative. -1, -2, -3. The y-axis, as we go up, we get larger values in the positive direction. And as we go down, we get larger values in the negative direction. Okay, so the x-axis is the horizontal one, and that's just like the number line that you learned back in like kindergarten or first grade. Right? The numbers get bigger as you go to the right, they get more and more negative as you go to the left. And then the y-axis is the same thing, it's just rotated. So as you go up, you get higher numbers. As you go down, you get lower numbers. And each point is the ordered number x, y. So let's do some practice. We're going to graph the following points. And I'm going to change my pointer into a dot. So the first point, A, -2, 1. So again, the -2 is the x. So I'm going to go -2 over in the x direction. The negative means I'm going to the left. So I'm going to go over to the left 2 and then up 1 because y is 1. And that's going to be right around there. So A is going to be in red. Okay, and then we have B, 0, 3. So x is 0, and that means that we're going to be on the y-axis. We're not going to move left or right. We're only going to move up, and we're going to move up 3 because the y value is 3. So B, it's going to be, I'll fix that, right around here. Okay, 0 in the x direction, up 3 in the y direction. For C, I'm going to do it in green. That is 2, -3. So 2 in the x direction, that's the positive 2, so we're going to the right. -3 in the y direction, so we're going to go down 3. It's going to be, I'll try to fix that. It's hard to be accurate on here. But 2 to the right, 3 down. The next one, D, I'm going to do in yellow. So -1, 0. So this time the y value is 0. So I'm not going to move up or down. And I'm only going to move to the left 1. So I have a negative x value and y is 0. The next one I'm going to do in black, 3, 2. They're both positive. So notice that's going to be in quadrant 1. If x is positive and y is positive, that's quadrant 1. So we're going over to the right 3 and up 2. I'll try to make that a little bit better. Okay. And then I'm running out of colors, so I'm just going to do another one in red for -1, -2. So both x and y are negative in this case, and that's going to be quadrant 3. So any point in quadrant 3 is going to have a negative x and a negative y. So x being negative 1 means I move to the left 1. Y being negative 2 means I move down 2. That's going to be right there. Okay. So the other part of this section is the domain. So the domain of a function are all the values of the inputs where the function is defined. So what can I actually input into my function and get out a real value? What we're going to do is we're going to focus more on what can we not put in. So we're going to remember the fact that we cannot divide by 0, so that's going to have an effect on the domain if I have a fraction. And the other one we're going to look at is square roots. Hopefully we remember that we cannot take the square root of a negative number. And what this means is that if we have a function that doesn't include these two things, so there's no fractions, there's no square roots, then the domain is what's called the set of all reals. And we have this notation here. So let me go out of my big dot for a second. These curly braces mean set. X just means that's my input. This symbol here, it's an epsilon, it means is in. So this is saying the set of x's that are in, and then this r is the reals. That typeset is called a blackboard R. So it's an R, but it's kind of like bubble letters almost. Sometimes when you write it, you'll write it like this. So you'll have just 2 of the vertical line for the R, and then 1 of the rest of the R. So if you're writing it, that's how you normally write it. Okay. So again, that says the set of x's in the reals. Okay. I don't really care that much if you use the set notation. If you want to put it in a sentence, that's fine. But the book does use it, so I want you to be able to recognize it. Okay. So determine the domain for the following. We have the function f of x equals 3x squared minus 3. So again, what we're going to look for are fractions and square roots. Hopefully you realize this doesn't have any, and so therefore the domain is the set of all x's that are real. So no matter what value I put in there, as long as it's a real value, I'm going to get out a real value. G of t equals 4 minus 7t. Again, there's no fractions and there's no square roots, so the domain is all reals. So in this case, it's the set of t's that are in the real numbers. H of z equals 4 over z. So now we have one of those problems. We have a fraction. So I know that I cannot divide by 0, and so what that means is that my denominator, which is z, cannot be 0. So this is the set of all z's in R, and then this vertical line here means such that. So this is the set of z's in the reals such that z is not 0. Okay. And again, if you want to write it as a sentence, that's perfectly fine. I just want you to be able to recognize it because the book likes to use this set notation. Sometimes this vertical line is also done by a colon. So you might see a colon, and that's the same thing. It means such that. Okay, so for our next function, y equals, let's get rid of that, y equals the square root of x plus 4. So now we have a square root, and that's going to be our problem. So we cannot take the square root of a negative, so that tells me that what's inside my square root, which is x plus 4, has to be either positive or equal to 0, right? I can take the square root of 0, that's perfectly fine. So x plus 4 has to be greater than or equal to 0. And then what I want to do is solve for x. So to get x by itself, just like if this was an equal sign, I'm going to subtract 4 from both sides. So if x plus 4 is greater than or equal to 0, then x is greater than or equal to negative 4. and that's going to be what's after my such that. So it's a set of x's that are real such that x is greater than or equal to 4. You can double check it. Plug in numbers that are greater than or equal to -4. Make sure you get out something that makes sense. Try something that's less than -4. If I wanted to do, say, -6, that's less than -4. I plug that in. That is not in the reals. So I don't want -6 because that's not going to give me a real value. So -6 is not in my domain. So this does make sense. It has to be at least -4. Okay. F of x equals 3x divided by x minus 2. So again, here we have a fraction, and we know that our denominator cannot be 0. And again, just like with an equation, I want to solve this by adding 2 to both sides. So if x minus 2 cannot be 0, then x cannot be 2. And for our last one, g of u equals 20 divided by the square root of 3 minus u. So here we have a fraction and a square root. So my whole domain is going to be based off of what's inside my square root. That's also in my denominator. So 3 minus u, I know that it has to be at least 0 because it's in the square root, but it's also in the denominator, which means that it cannot actually be equal to 0. So if you have a square root in the denominator, it's not going to be greater than or equal to 0, it's going to be strictly greater than 0. I cannot plug 0 into that equation inside the square root, inside the denominator. Okay. U itself can be 0, right? If u was 0, I'd have 20 over the square root of 3. So u can be 0, but the 3 minus u cannot be. And just like before, I'm going to solve this. So I'm going to add u to both sides, and that's going to give me 3 greater than u. Now 3 greater than u is perfectly true, but we tend to like to keep things in terms of u and then something. So I'm going to reverse that, and if 3 is greater than u, then u is less than 3. And that's going to be our answer. And again, you can always check it. Plug things in that are bigger than 3, plug things in that are less than 3. Make sure that when you're plugging things in that are less than 3, you're getting out a number. And if you're plugging in something bigger than 3, you're not. So again, if I wanted to plug in, say, 5, 3 minus 5 is -2, I can't plug that in. So I do want u in the real such that u is less than 3. Okay, so again, you have denominators cannot be 0, square roots are greater than or equal to 0, and then if they're together, it's strictly greater than 0. Okay, so make sure that you read through the section, try out the homework, and let me know if you have any questions. Thanks.